Welcome back, ladies and gentlemen. Thank you for joining me. We're doing a new series today, starting today on the channel, and it's all revolving around Unreal Engine 5. I jumped into it about a month ago or so, learned a little bit, and started a project. So now I'm going to start from scratch, and I'm going to bring you all along with me. So if you ever wanted to learn how to use Unreal Engine, this is the time for you to start and to join me. So with that out of the way, I'm going to jump right into it. Here we go. I've got Unreal opened here. Recent projects. See, this is the one I've been working on. This is a sample project. So we're going to go to games, and what we're going to do is we're going to start a blank project. See, a clean, empty project with no code. So I'm going to name it just Balls V2. I'm going to be working with blueprints, quality max, starter content. Yeah, we'll use some of that starter content. And why not ray tracing? Let's do it. So it might take a minute or so. First time you do this, just give it some time to build those shaders, and then we'll jump into it. So let's go over our blueprint, what we have so far, what we built today together. This is on our Marble blueprint. We start off with the controller, and this is the event begin play, that central node. So we get player controller, we input it into a cast, and we're going to cast it into enhance input local player subsystem. Check, make sure the cast was successful with an isValid node. And then from there we add the mapping context, which is the one that we created, input IMC controller. From there, the simplest one was the look function. Enhanced input action IA look, controller pitch, and controller yaw. Pitch is with the y-axis, and x-axis is for the yaw. Our move is activated with the input action move node. We split these action values into separate ones, x and y, because it is a 2D axis node. And we used get control rotation to get the current position of our player controller. We drop off of the y, the yaw, and make a rotator, and then split it from its forward and its right vectors. This is a clean way to get information from your WSAD as well as your gamepad. We can just pull off this one value and get the forward and the right vectors. So with the forward vector, we're going to multiply it by a move force. First of all, the move force is going to be multiplied by this y action value. Y action value is somewhere between 0 and 1. So we're going to have to multiply it by a force. We have, what's that, 50,000. And the result of that is going to get multiplied by the direction, which is going to be informed by this forward vector, and then the result of that is going to go into our force. And so that's forward vector force, and then this is the right one. Same thing, we've got a move force that's multiplied by the x value here. That output is going to be multiplied by the right vector, and then we put it into our add force component. Marble is our target. Okay, next we have the jump. Jump is drawn off the IA input action jump node. We created a boolean called can jump and set as default as true. Pull off there, you can create a branch, and if that condition is true, then we'll move on. We're going to set the condition to false so that we don't forget to do that at the end. We can do it right away. And then we're going to add our impulse for our jumping force. Target's marble, and then we have to talk about which direction and how much. How high? Jump force is a variable we created over here, a float. We gave it a starting value of 5,000. I multiplied it by 10 because I was having a hard time finding out the right value. We could take this out probably and just input the number. Maybe it would optimize things a little bit. Either way, I'm going to pull out into a make vector. Make sure I put it into just the up and down axis, which is the Z axis. So I'm just jumping straight up and down. And then the return value goes into impulse. That is all for the jump, but how do we reset our can jump boolean? One quick easy way is use the event hit node, and this is going to event when this actor bumps into blocking object or blocks another actor that bumps into it, etc. So pretty much anything that you bump into is going to trigger this node, which is then going to say, oh, you can jump again. This means you can't jump multiple times in the air at the same. You can't jump multiple times in the air like a double jump or a triple jump, but as soon as you hit a surface, it resets that trigger and you can jump again. That will let you kind of scale surfaces if you want, which I'm leaving in the game for now. I may play with this later to figure out what is the appropriate time to reset that hit can jump boolean, but I like this. Moving on, dash. We have a dash which is triggered by the input action dash node. We have a boolean that we created called can dash. Default value is true. Set it into a branch condition. If it's satisfied, we'll kind of as the same as up here. Set it to false so we don't forget. We're adding an impulse just like we did up here. I'm also adding an angular impulse in degrees so that we get some rotation on the ball when we dash. It's not just like moving forward kind of without any rotation. It looks a little funny. From there we're going to start a field of view change, which is a custom event that we created here. Going to let a small delay of 0.3 seconds, and then we're going to trigger the end field of view, which is down here. And then we're going to give a delay of 3 seconds. This is how long you have to wait between dashing. That's something you can play with. The number here, maybe you want something that is a little more complicated, but a simple delay works just fine. And then once that delay is over, we set the can dash to true, so we allow ourselves to dash once more. This down here, how hard and what direction to dash, is established by the same setup we have in move. We had a get control rotation. We made a rotator from the yaw output, split it into a forward and right. Down here we don't need the right because we're just going to go forward with our dash. Kind of played around with this before, but I settled on this design decision because pushing forward works really good with the field of view change, and we're going to put in maybe some particle effects, and so I like going straight forward away from the camera. This is a pretty cool dash. So using the forward vector, we're going to create a dash force or float variable down here, and we gave it 10,000 as a default. I multiplied it by 10, kind of like I did up there, or here rather, with a jump. Then multiplied the forward vector by this kind of value, float value, and then I split the pins so I have access to the 3 axes. I'm going to pull off the X and Y and put it into the impulse. I don't want to use Z because dashing up or down is not what I want for various reasons. Dashing down, you have a tendency to have that ball punch through the mesh, and then you'll just die or whatever. It breaks the game. And X and Y is fine. We'll use those. Angular impulse in degrees, what I'm doing is I'm pulling off the value for X, and instead of going straight into X here, I'm dividing it by 5 because I find this value to be pretty strong for the angular impulse. So divide by 5, put that into X, and the rest is the rest. Coming down to field of view, we're going to trigger that start field of view as a custom event like I said, and we have this boolean has applied FOV. It is set to false for now, and we have this not boolean structure, so it says it's going to make sure that it has not applied FOV as the condition, and we're going to move on and then say immediately that yes, we have applied FOV before we forget we did, and then we move on. We're going to grab from the camera component and get its current field of view. So you can grab off this, pull off and say field of view. Then we're going to come off this and say set the old field of view. We're going to plug in the value, so that's going to trigger a timeline. In the timeline we have, if you double click it, it opens up the timeline tab here. We set a length for the timeline to play as a quarter of a second, and it goes from 0 to 1, and we added just a nice smooth in, smooth out. From there we updated to set field of view, which is going to take the value of a lerp, and lerp means alternating or interpolating between 2 things. So it's going to interpolate between our old field of view and the new one, which we just add 20 to. This number you can play with. You can make it bigger or smaller if you want bigger or greater effect of your field of view change. And that's we're grabbing this FOV track, that's the output. That's what we called this here. When we add a new track, we call it FOV track, and that pops up on the timeline. So we pull that out as our alpha, into the lerp, and then A is the old and B is the new. Then that's our return value. So for the set field of view, it's going to be changing with time based on our timeline. Target is camera, and then I'll come back to this in a second. We're going to end the field of view. We're calling it up here after 0.3 seconds. So this whole field of view change is going to last for 0.3 seconds, and then we're going to trigger end field of view. And what that does is we're going to make sure that we have applied the field of view, which should be true at this point. So if it's true, we're going to continue on, and we're going to plug in to reverse the timeline. So it's going to go backwards down that ease in, ease out slope. So direction, we're going to see if this direction is going backwards, make a condition in a branch, then we can say set has applied field of view to false. So we're kind of resetting everything for the next time we want to run the field of view event. And then we go finished into the branch. So from when this timeline is finished and it's going backwards, then we can say, okay, we're all done that cycle, and we're going to say false to the has applied field of view, so we're ready for the next time we call it. Those are our 1, 2, 3, 4, 5, 6 input actions that we created today. There is a 7th called swap right here, and we're going to use that one in the next video. We're going to make a second player controller, and we're going to create the ability to swap between the two of them live while you're playing. It's going to be fun, and let's see. So let's go save everything, save all, and we'll play our game one more time real quick here. So you have the camera movement. I'm using my mouse right now. I've got WSAD, W forward, S backward, A left, and D right. And it adjusts what right is based on my camera view, which is always good. We have a jump with the space bar. I can't jump in the air more than once, but as soon as I land, I can jump again. Finally, we have a dash with the E button. And I can only do it every 3 seconds. I'm spamming it, and it doesn't work, and then, oh, and there we go. And we got that field of view change, which doesn't look all that dramatic. Maybe you want to increase that value of 20 to something bigger. Let's do that right now. Down here. Let's put it at 50 and see what happens. Oh, that's cool. Too much though, I think. Let's go 35. And maybe we make it last a little bit longer before it reverses. What did we say, like 0.5? Wonder what this is going to look like. No, I don't like that at all. The time is weird. We'll put it back to 0.3. That's cool. It might be still a little too dramatic. But you can play around with it. Find what settings you like for yourself. Oh, no, I think I like it. Okay, that's all for today. Thank you for joining me. My name's Chris. We'll be doing lots more Unreal Engine stuff on the channel, so subscribe, like, all that stuff. Thanks, guys. See you next time.